6.4, Properties of Rhombuses, Rectangles, and Squares. The objective in this lesson is to classify special types of parallelograms and to use the properties of the diagonals of rhombuses and rectangles. Now, one of the first things we should probably note here is, let's remember, what's the definition, or what are our properties of parallelograms? What's a parallelogram got? Parallelogram has opposite sides are parallel. That's our definition, right? Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Opposite angles are congruent, both pairs. And all pairs of consecutive angles are supplementary. And what was the last one? That's right. Diagonals bisect each other. So both of them are bisected. So that was 6.2, parallelograms. Those are our properties of parallelograms. So let's do some definitions here. A rhombus is a parallelogram. It means it possesses all 5 of those properties. And it's special because it has 4 congruent sides. So here we have a parallelogram, and if all 4 of our sides are congruent, then we have a rhombus. It is a special parallelogram. Next, we have rectangle. Rectangle is a parallelogram. So all 5 of these properties. And what makes it special? 4 right angles. So we have a parallelogram here. It has 4 right angles. It becomes a rectangle. And our last one, a square, is a parallelogram, all 5 of those properties, and it has 4 congruent sides and 4 right angles. So what do you notice about our square here? It's got 4 congruent sides and 4 congruent angles. A square is a rhombus plus a rectangle. It has properties of both. So a square is a rhombus. Not all rhombuses, not all rhombuses are squares, but all squares are rhombuses. A square is a rectangle. And again, not all rectangles are squares, but all squares are rectangles. It has the required properties of it. And we can look at this as a Venn diagram. Here we have our rhombuses, and we have our rectangles. And where do they overlap? Right here in the middle as a square. All right, let's start to use some of this. Let's take a look at our first problem. Classifying special parallelograms. Is parallelogram ABCD a rhombus, rectangle, or square? Explain. That means we have to have a postulate, theorem, or definition of proof. So let's look at ABCD here. There's ABCD. I'm going to highlight it. We draw, and label. So what's the first thing I know about this? Well, I have a right angle here, and we know it's a parallelogram. So what do we know? We know that opposite angles are congruent. That means that this angle is a right angle. And I also know that consecutive angles are supplementary. So if this is a right angle, then angle C has to be a right angle, and angle A has to be a right angle. So I have a parallelogram with 4 right angles. Can we do anything more with it? We don't have any knowledge about sides or anything. So it looks like all we've got is a rectangle. Parallelogram with 4 right angles is a rectangle. Looks like it's your turn now. Go ahead and pause the video and do problem number 1. We wanted to know, Is parallelogram, EFGH, a rhombus, rectangle, or square? So I drew my EFGH here, and we were given that these two sides were congruent. And what do we know about parallelograms? Well, we know that opposite sides are congruent. And then I can say my other two opposite sides are congruent. And so I can make all sides congruent. We can put all sides congruent by the transitive property of congruence. If you know these are congruent and these are congruent, then everybody's congruent. So I have a parallelogram with 4 congruent sides. That is a rhombus. So I hope you enjoyed that problem. That was kind of fun. All right, let's look at our theorems for this chapter. Our first theorem, as you see, not named, but that's okay. These are short. It says if a parallelogram is a rhombus, so our requirement is a rhombus, a parallelogram with 4 congruent sides. So that's how we know we have a rhombus. Then what happens? The diagonals are perpendicular. Now this is special, right? We like right angles. So this one we can write rhombus, diagonals perpendicular. See, it doesn't have a name, but that's shorter than some of the names we have. So if our parallelogram is a rhombus, then our diagonals are perpendicular, and we can automatically draw in that right angle there. And as soon as that's a right angle, all 4 of these are right angles because perpendicular is perpendicular. Let's put that in red. That is really important. We're going to put that in red. All right, what's next? Ooh, another one about rhombuses. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. A lot of words there. So we have our rhombus. And then what happens? Our diagonal, both diagonals, this is both diagonals, bisect your opposite angles. So we have 2 congruent angles. So that means that angle 1 is going to be congruent to angle 2. Now think about this. What do we know about the opposite angles of a parallelogram? We know that, I don't want to call it angle A, we'll call it angle BAD, right? Angle A up here is congruent to angle DCB. And so if our whole angles are congruent, right? Angle 1 plus 2, this is 1 plus 2, and this is 5 plus 6. So if 1 plus 2 is congruent to 5 plus 6, and 1 is congruent to 2, what are we going to be able to say? We are going to be able to say that 1 and 2 are congruent to 5 and 6, because we know that 5 and 6 are congruent because our diagonals bisect the opposite angles. So all 4 of those angles are congruent. And let's look at the other set here. I can say angle 3 is congruent to angle 4, right? Because we know that diagonal bisects that angle. But what else do I know? I know that angle ADB is congruent to angle CBA, which is 3 plus 4 and 7 plus 8. So by what we just did, we know that 7 and 8 are congruent, but we also know that 7 and 8 are congruent to 3 and 4. So we know that angle 1 is congruent to angle 2, which is congruent to angle 5, which is congruent to angle 6. And we know that angle 3 is congruent to angle 4, which is going to be congruent to angle 7, which is congruent to angle 8. So not only are opposite angles bisected in a rhombus, but all 4 of those angles are congruent as well. So this one might be a little hard to remember, but it's a good one, so you should study up on it and learn it. All right, I bet we get to use this now. Yay, this lets us find angle measures. So we are asked to do, what are the measures of the numbered angles in rhombus ABCD? So we know we have a parallelogram plus 4 congruent sides. So all of our parallelogram rules apply here, as do our rhombus rules. So we have 4 congruent sides. We know, what do we know about a rhombus? We can do angle 1 right here because what do we know first off? We can do the measure of angle 1 is 90 degrees because it's a right angle. The diagonals of a rhombus are perpendicular. So we've got one angle down right now. All right. What about angle 2? Well, what else do we know here? We know that, oh, there's so many ways to do this. They do it by alternate interior angles. We know that the diagonals of a rhombus bisect the angles. So I can make that one 58 degrees. Right? But what else do we know about rhombuses? Rhombuses are parallelograms, so your opposite angles are congruent. We also have alternate interior angles, which is hugely, hugely useful with parallelograms. Back to chapter 3. So I can say this angle is congruent to this angle, right? Those are my alternate interior angles. If I draw my parallel lines here, parallel lines cut by my transversal, then we've got this angle and this angle, right? So we know that angle 2 is 58 degrees by alternate interior angles, and we're also going to know that angle 3 is 58 degrees because the diagonals of a rhombus bisect the opposite angles. So we've got a lot of ways of getting the same thing here. And now we need to find angle 4. Well, let's hit chapter 4 again. Triangle angle sum theorem says that 90 plus 58 plus the measure of angle 4 is 180. So we can find that angle 4 here measures 32 degrees. And if we wanted to continue on, we know that this is 32 degrees, this is 32 degrees, and this is 32 degrees. Because the diagonals bisect opposite angles, and we have alternate interior angles, and we also know that the opposite angles of a parallelogram are congruent. And we also know that all of these are 90 degrees as well, right? A whole bunch of right angles in there. So rhombuses are pretty cool. And guess what? It's your turn again. Go ahead and pause the video and do the next problem. This was a fun problem. We have a rhombus and we want to find the measures of the numbered angles. Well, we only have one angle in the whole rhombus, right? So what are we going to do? Well, did you mark the sides of your rhombus congruent? Because if you did, then you should see that it makes isosceles triangles. And if we use the isosceles triangle theorem, we know that angle 1 and angle 3 are congruent, which means we can use our triangle angle sum theorem x plus 104 equals 180, and we get x equals 38 degrees. So, and we just call this x and that x, right? They're the same. And so if I know angle 1 is 38 degrees, and I know angle 3 is 38 degrees. And then what else do I know about a rhombus? I know in a rhombus that the diagonal bisects the opposite angles. So if angle 1 is 38 degrees, I know that angle 1 and angle 2 are congruent. So I can just say angle 2 is 38 degrees. If I know angle 3 is 38 degrees, I know angle 4 is 38 degrees. Now, another way you could have done this would, I'm just going to draw a quick rhombus here, is you know that this is 104. So rhombus is a parallelogram. I could have said this is 104 because opposite angles are congruent. And if I know opposite angles are congruent, then I know that this big angle here and this whole big angle here are also congruent. I could have called them x and x, right? And then I could have solved for those and then cut them in half because I know the whole thing is 360, right? So 2x plus 208 equals 360. Guess what we're going to get? 2x, that's a 0. 2x is what, 152? And guess what 152 divided by 2 is? X would be 76. 76. And then we need to bisect it. So 76 divided by 2 is 38 degrees. And look, we've got the same 76 over here, right? Because we're only dealing with half of it. So a couple of ways you could have done that. Hopefully you saw the isosceles triangles. I would still be proud of you if you saw it as a quadrilateral with all of them are 360 and opposite angles are congruent. In the end, we still have to bisect the opposite angles with that diagonal. So it's all good either way you did it. Looks like we have another theorem here. The diagonals of rectangles have a special property. What do you suppose that is? All right, if a parallelogram is a rectangle, then guess what? Your diagonals are congruent. Yay! Rectangle, diagonals, congruent. All right, so if we have a rectangle, how do we know a rectangle? A parallelogram with 4 right angles. Okay, then what do we know is true? We know that segment AC is congruent, this whole thing here is congruent to segment BD. And then what do we know? Just looking forward on this, and then what do we know? We know that in a parallelogram, those diagonals bisect. So do you see a whole bunch of isosceles triangles there? Good stuff. They bisect each other and they're congruent in a rectangle. All of that is good. Okay, so it looks like we have a problem here, an example. Finding diagonal length. In rectangle, that's important, rectangle, RSBF, we know that the length of SF is 2x plus 15 and the length of RB is 5x minus 12. How long is each diagonal? Well, we know that the diagonals are congruent, so that means their lengths are equal. That's just definition of congruence. Set them equal, do our math. We know that x is 9, substitute back in. And how come we only need to find one of these? All they found was the length of RB is 33. Because they're congruent. So if we did the length of S, it's not even close, If we did the length of SF, 2x plus 15, put in 9 plus 15, what are we going to get? 18 plus 15. Guess what? The length of SF is also 33 units. So we only need to find one because they're congruent. So if we know one, we know both. Looks like it is your turn to do the last problem here. So go ahead and pause the video and get that done. This was an easy problem. We were given the lengths of the diagonals and told we had a rectangle. And we know in a rectangle, diagonals are congruent. So that lets us say that their lengths are equal. I did my algebra, found out that x is 15, substituted back in. The length of ln is 43 units. I could simply say that the length of MO is also 43 units, but I did the workout anyway to prove it. So that should have been an easy problem. Now, do you notice that we have done nothing with squares? And why is that? Because squares have all of these properties. So if you have a square, the diagonals are congruent. If you have a square, the diagonals bisect your opposite angles. Okay, if you have a square, all four sides are congruent. No, that wasn't it. Oh, the diagonals bisect the opposite angles. I think I already said that. Oh, your diagonals are perpendicular. So we get really special triangles. Let's take a look at a square here. We'll just draw up a quick square. Where do I have a quick square? There's a quick square. So if this is a square, okay, I know my diagonals are congruent and they bisect each other. And I know my diagonals, because it's also a rhombus, right, are perpendicular. And I know that because a square is also a rectangle, that these are all right angles, right? So I know that my diagonals bisect those angles, which is going to cut those into 45-degree angles. And so what do I end up with? I end up with isosceles right triangles, which these are 45 degrees. So squares are super duper special, and we will be dealing more with those. All right, now it is time to get out our classification chart and fill in some more stuff. So I will see you with the classification chart. Okay, we can add quite a bit to our classification chart here. We can add in a rectangle, which is a parallelogram plus, don't forget all 5 of our parallelogram things up here, a parallelogram plus 4 right angles. That's our definition of a rectangle. And in a rectangle, diagonals are congruent. And we can add on our rhombus, which is a parallelogram plus definition, 4 congruent sides. Parallelogram plus 4 congruent sides. And a rhombus, we know the diagonals are perpendicular. The diagonals bisect the opposite angles. There we go. Diagonals bisect the opposite angles. So that's the 5 parallelogram things plus a definition plus 2 more for a rhombus. That's 8 things we know about a rhombus. 7 things we know about a rectangle. And so for our square, which is a parallelogram plus 4 congruent sides and 4 right angles, that's our definition, right? We have everything from the other 2. So from our rhombus, diagonals are perpendicular and diagonals bisect opposite angles. And from our rectangle, diagonals are congruent. So a square has 5 parallelogram properties plus 5 more special properties of its own. This quadrilateral classification chart is going to be invaluable. Make sure you give it a place of honor in your notebook and you fill it out and you study it. I believe that you will have a ton of fun doing homework on rhombuses, rectangles, and squares. So enjoy.